Hello students, let us start a new topic called differentiation. Differentiation is the beginning of calculus. In fact, we have already developed basic knowledge in functions as well as limits. Now differentiation, here we are going to study about differentiation as a measure of rate change. It is a very important part in understanding physics and somewhere in chemistry as well. To study differentiation as a measure of rate change. Now what is the meaning of rate change? You know that when one physical quantity changes with respect to another physical quantity, this is a type of rate change. Rate change always does not necessarily mean change of one physical quantity with respect to time. So it could be, for example, variation of gravity due to height or depth from the earth. That is also a kind of rate change. So rate, usually in our day-to-day life we associate a rate change with respect to time, but in physics as well as in mathematics it is possible that two physical quantities are varying with respect to each other. So we can measure any kind of changes in physical quantity. Say one is independent quantity, which we have already learned from functions. There is one independent quantity and another is dependent quantity. For example, students, let us consider this particular pipe. So here water is flowing through this pipe. Now the velocity of the water will be maximum at the axis of this particular pipe, and as you move away from the axis towards the end of this particular pipe, you will find that the velocity keeps on decreasing. Velocity of the water keeps on decreasing. So this means we can always find rate of change of velocity with respect to this diameter of the pipe small d. So this is also a type of rate change. Students, before we get into the differentiation broadly, before we get into differentiation broadly, it is important to understand little history which is very interesting of calculus. Two great mathematicians, Leibniz and Sir Isaac Newton, were initially involved with the foundation of calculus. In fact, the foundation of calculus were laid by Leibniz and Newton simultaneously. Leibniz, while he was interested to find out whether it was possible to find tangent to a curve. Similarly, Newton was trying to find out the rate change. In fact, Newton was really interested to find out velocity or acceleration at a particular point of time. So these two mathematicians put their ideas in the form of calculus. Students, let us try to understand this particular graph. Here we have drawn a graph which consists of a curve. We have two axes x and y. Here we are choosing two quantities y and x, which is interrelated as follows. This is the length x and this is the length y. Here, as you can see, we have pointed out 2 points on the curve, which is A and B. From A and B, we draw perpendicular to the x-axis so that we can find a distance delta x. So this particular distance is basically delta x. Similarly, we can also see that this particular height can be given as delta y. So students, in the graph we can see that as x changes to delta x, y changes to delta y. So students, x changes by delta x and y changes by delta y. So we can write down the rate change as delta x divided by delta y. Students, if you try to locate the coordinate of the point A and B, we can obtain it as follows. Here the coordinate of the point A will be nothing but x comma y, and similarly the coordinate of the point B will be, of course, x plus delta x and y plus delta y. So this is the coordinate of the point B. So students, here we can write down the slope of the line AB as del y by del x equals to, see, from this triangle ABC we can write down BC by AC. The slope of the line AB is nothing but tan theta. This is tan theta. So we already know slope is given by tan theta. So tan theta is P by B. So it is of course BC by AC. But students, still we have some problem with this particular equation because here we have only written the slope of the line AB is equal to del y by del x. Now the problem is, if you look into this particular line AB, the value not only changes at the point A and B, but in between A and B there are changes. So students, here we can see the curve is steeper at the point B compared to A. So students, if we really want to find out a particular value of at which y changes with respect to x. So students, if we really want to find out the changes of y at a given point of x, then we need to find out something which can be considered at every point of x along this particular line AC or along the x-axis. Remember students, this slope of line AB can only give you the entire change in the region of AC and BC. But if we really want to find out what is the particular value of y at a particular point of x, then this particular slope of line is not able to give you the exact value. This means we have to bring some kind of changes to this particular equation. Now what we can do? Students, we can bring this particular value of del x very closer. So as this value of del x comes very closer, the value of del y also decreases. Remember student, what I am trying to say here is, if the value of del x comes very close, this height del y will come, this particular height del y will also come very closer or shorter. So in this case we are able to identify a particular point at x and what is the value of y at that particular point. So students, let us make del x smaller and smaller. Then in this case the slope of the tangent comes very closer to the point A. Students, this can be mathematically written as del y by del x. Let us take a limit del x tends to 0. So we have already learned the meaning of limit del x tends to 0, which means delta x is very close to 0 but not equal to 0. So when we write down or when we say delta x is very close to 0, this means we are able to find out any particular point at delta x and its value, and in fact what is the value of y at that particular point x. So this can obviously be written as dy by dx. So the moment you apply limit delta x tends to 0 to the rate change delta y by delta x, it becomes dy by dx. This particular format dy by dx is called differentiation of y with respect to x. So with this equation dy by dx, we are now in a position to find out any variation of y with respect to x at any given point. Now students, I am sure you must be very curious to know what is the application of this particular system of mathematics in physics or any other science. Students, I have told you earlier that whenever we are using equation of motion for a uniform motion, we are not able to find out the velocity or acceleration at a particular point of time, because say in case of uniform motion at a particular point of time there is no change in velocity. But what happens if there is a non-uniform motion? So in case of non-uniform motion at a particular point of time, the velocity or acceleration may change. So if the velocity and acceleration is changing, in that case, at a particular point of time, in that case, we are not able to use the equations of motion algebraically. So in that case, we have to utilize the same equation of motion in terms of calculus. For example, students, if I ask you what is the velocity of a car at a particular point of time, say 0.001 second, it is very difficult to utilize normal algebra and find. Now students, our next topic in differential calculus is maxima and minima. Suppose students, a physical quantity y depends upon x as shown in the graph. Say y reaches maximum value at a1 and similarly y reaches minimum value at the point a2. Now why I am saying at a1 there is a maximum value, because you can see there is a tangent drawn at the peak level and this tangent is parallel to the x-axis. Similarly, there is another tangent at the minimum value a2 where also you can see that there is a tangent drawn parallel to the x-axis. So students, let a quantity y depends upon x as shown in the graph. So it becomes maximum at a1 and minimum at a2. Students, as I said, if you see the tangent in these two particular region, you find that these tangents are parallel to x-axis. So here the tangents are parallel to x-axis both at the point for the point a1 and a2. And thus we can say the slope tan theta equals to 0. So why this slope tan theta is equal to 0? Because the tangent is parallel to x-axis in both the cases, a1 as well as a2. So thus for a maximum or minimum value we can write down the rate change as dy by dx is equal to 0. So since the slope tan theta is equal to 0, so that is why we are writing dy by dx is equal to 0. In the graph you can see that just before the maximum the slope is positive. So you can see just before maximum the slope, this particular slope is positive. And obviously at the maximum it is 0. So we can write down at maximum slope is 0, and obviously after the maximum the slope is negative. So we can write after maximum slope is negative. So slope is negative basically in this particular region. So students, whenever you want to find out any maximum or minimum value, then we have to put dy by dx equals to 0. That is, variation of one physical quantity with respect to another physical quantity must be equal to 0. And then of course we can differentiate and solve the equation to get the maximum or minimum value. It has plenty of applications in physics. For example, what is the maximum force acting between the charges? What is the maximum value of gravitational force? What is the maximum value of gravitational force, etc.